In this video, we're going to apply concepts of from energy and also from momentum in order to figure out the speed of blocks and also the compression and springs and all those things. Okay, so what's happening is this: you have a spring-loaded gun, and we take a ball of mass 0.2 kg, and it compresses this spring by an amount of 0.12 meters. And it releases the block. So this block, after being released, moves ahead and strikes the second block. Now, what is observed is right after the collision, the block 2 of mass 0.5 kg moves along this parabolic path, and it lands 0.5 meters from where it started. Okay, and our question is, we're going to do a bunch of things. Okay, so there's several layers to the question. The first is going to be, we're going to find the speed of the 1 kg block right after the collision. Then we're going to find the speed of the 0.5 kg block right after the collision. So first we're going to find the speed of block 1, which is the 0.2 kg block right after the spring lets go of it. Okay, so this is after the spring lets go of it. Okay, then we'll find the speed of the second block right after the collision, and then after that we'll find the speed of block 1 right after the collision. So V1 after the collision, V of block 1 right after the collision, V1F, this is going to be V2F, and this is going to be V1I in the beginning. Okay, so lots of things going on in the problem. Again, what you have to do is, for problems that involve several things, you need to learn to break it into smaller components. And in this case, the spring block mechanics, okay, all that is happening there can be broken into one part. So that's one part where the mechanical energy is conserved. Then this block goes ahead, strikes the second block. That's where momentum conservation will be used, because you haven't been told that the collision is elastic or no. In fact, that could be one of the questions. Hey, what kind of a collision is it? And then the third one is, where this 2 kg, this 0.5 kg block moves along a parabolic path. So, several things going on. We'll have to use different concepts. Like we have projectile motion, we have energy conservation, we have momentum conservation, and we'll have to use all the concepts depending on the part that we're looking at. So the first thing we'll do is find speed of 1 after release by the spring. Now when we do this, okay, again you have to ask yourself, what is happening? It's clear in this case that the mechanical energy is what is going to be conserved. The total mechanical energy in the beginning is equal to total at the end. Now I hope that by now you have enough experience to know what is composed of the mechanical energy for the spring block system when the spring is compressed. Okay, so we have 0 and 0 for the block, for no kinetic, no potential, but we have all potential for the spring. So it is 1/2 200 times 0.12 square. Now on the other hand, at the end we have all kinetic energy for the block, so it is 1/2 times 0.2 times V1 square. Great, so we have all this. Let's figure out the speed of the block now from here. So the half cancels, the 0.2 moves to the other side with 1000, and then 0.12 is 0.0144, and this ends up giving us V1 square is equal to 14.4. So this gives us V1 is equal to square root of 14.4 meters per second. So this is about 3.8 meters per second. Alright, so now we know the speed of the first block right after the collision. Right after being let go by the spring. So as far as the collision is concerned, this V1 is the initial velocity for the momentum part. So keep that in the back of your minds. Okay. Now the second thing we're going to do is we're going to find speed of block 2 right after the collision. Okay. Now here the common mistake would be to think, hey, okay, we have to use momentum conservation to do this. But in order to use momentum conservation, we need to know things. We need to know with what speed block 1 bounces after the collision. We do not know that yet, okay? But what we know is that the second block, okay, travels along a parabolic path, okay, and it goes 1 meter down and it travels 0.5 meters across. So we can use the projectile motion in this case to figure out the speed with which this guy travels. Okay, this is the v2f because that's the velocity right after the collision. But as far as the projectile motion is concerned, this is some vi that we're going to look at. Okay, so let's set up the chart for the projectile motion. And if you do it correctly, what you have is you'll have two equations. First, we'll have to find the time, and the time can be found by using this: -1 equals -4.9 delta t squared. I hope that you guys know where this equation comes from, and that gives me delta t squared equals 1 divided by 4.9, which is equal to 0.20408163265, and so on and so forth. So that gives us delta t, which is equal to square root of this beautiful number, and we end up getting so this gives us a value of 0.45 seconds. Alright, now that we know the time, we can use this equation, delta x equals vi x delta t, to figure out vix. So vix is equal to delta x, which happens to be 0.5 divided by 0.45, and that gives us 1.11 meters per second. Great. So we have the speed. So this now happens to be nothing but v2f, because this is the velocity of block 2 right after the collision. Alright, great. Now we have all the parts for the collision itself. Okay, so find velocity of block 1 right after the collision. So we can figure this out now. And for the collision, we're going to use pi equals pf. And what we know is we know the velocity of block 1 right after being let go by the spring, which is 3.8. And we know the velocity of block 2 in the beginning. So what we have is we have 0.2 times 3.8 plus 0.5 times 0, because the block 2 was initially at rest, and this is equal to 0.2 times v1 final plus 0.5 times 1.11. Right? There is simple algebra right here, and we get 0.76 is equal to 0.2 v1f plus 0.5 of 1.11 is equal to so this gives us 0.2 v1f is equal to 0.76 is 0.55, which is equal to 0.21, and this gives us v1f is equal to 0.21 divided by 0.2, which is approximately 1 meters per second. Okay, great. So what this tells us is right after the collision, block 1 continues to travel in the direction of block 2. It doesn't bounce back, it actually moves in the same direction. Okay, now once we know this, we can go ahead and find also how far block 1 lands from the edge of the table, and we can ask now what is the separation between the two blocks once they land on the table. Now in this problem, that's what happened. In another case, we could have some situation where something goes up on a hill, or something comes back and compresses the spring again. All these things are possible. So whatever you have, you need to make sure that you have proper tactic to take care of things. And again, the lesson here is to just realize that there are several things going on. Break the problem into all these components and figure out, okay, it could be energy conservation, momentum conservation. In this case, we also have projectile motion. So all these things happen. All right.